Good morning, children. Today we are going to start our first chapter, Matter. I hope you all are fine. Please take out a textbook and open first chapter. You know that matter is made up of tiny particles called molecules. Last year we have already discussed this point about the molecules. And that molecules are held together by a force of attraction called intermolecular force. In between the molecules there is a particular type of force. That force is called intermolecular force. The molecules are held together by a force in between, that is called intermolecular force. There is also a space between the particles called intermolecular space. The space between the molecules, that is called intermolecular space. Okay. Then here we have one diagram to describe what is intermolecular force and intermolecular space. Here in this diagram it shows intermolecular force, the force in between two molecules. And second one, it is intermolecular space, the space between the molecules, that is called intermolecular space. The force of attraction and also the space between the particles differ from substance to substance. But for any substances, the stronger the intermolecular force, the smaller is the intermolecular space. If the intermolecular force is strong, the intermolecular space is less, and the weaker the intermolecular force, the larger is the intermolecular space. Okay. And here it comes the topic states of matter. We know that each and every substance occupies in its own states. You have learned earlier that matter exists in three states: solid, liquid and gaseous. For example, water exists in three states: ice, water and water vapor. Ice is in solid state, water is in liquid state and water vapor is in gaseous state. Here we must understand that the kind of matter. The molecules constituting ice, water and water vapor is the same. The chemical formula of the water, we know that 6th class onwards we are discussing about the molecular formula of the water, that is H2O, that is H2O. 2 atoms of hydrogen and 1 atom of oxygen constitutes water. Then what causes the difference in states? Now we discussed that the substances are in different states, either in solid or liquid or gaseous. For any substance, the molecules making up the substance do not change in the three states. Then why is it that the substance exists in three states? It is in fact the force and the space between the molecules that determine the state of matter. The force and the space. The force here means the intermolecular force, and the space means intermolecular space, which we have discussed earlier. The intermolecular force is the strongest in the solid state. We discussed that there are three states: solid, liquid and gaseous. In solid state, the intermolecular force is strongest. In intermolecular force is strongest in solid state, weaker in liquid state, and weakest in gaseous state. And also about the intermolecular space. If you are going to discuss about the intermolecular space, the intermolecular space is smallest in solid state and larger in the liquid state and the largest in the gaseous state. So, once again the intermolecular force is strongest in solid state, weaker in liquid state and weakest in gaseous state. And about the intermolecular space, it is the smallest in solid state, larger in the liquid state and largest in the gaseous state. In this diagram, figure 1.2, please observe, it shows intermolecular force decreases as intermolecular space increases. How molecules held in liquids, solids and gaseous. You see, in solids, here in solids the molecules are arranged tightly, but same time in liquid you see the molecules are loosely arranged. In gaseous state, molecules are arranged too far. Okay. Thus, the molecules are most tightly held in solids. Thus, we can say that, we can confirm that the molecules are most tightly held in solids, loosely held in liquids and almost independent of each other in gaseous. This explains the general behavior of solids, liquids and gases. Okay. Understanding now? Now we have the topic interconversion of states of matter. Interconversion means from one state to another, the substance changing from one state to another state. As you know that on heating, here also you can take the example ice. On heating, ice turns into water and water into steam, and on cooling, you see steam turns to water and water into ice. Such a change in state may be brought about in other substances too without a change in the composition. So, generally we can show this one in a graph. Solid state by heating changes to liquid state, by heating again changes to gaseous state. By cooling, the gaseous state changes to liquid state and liquid state to solid state. This is called the interconversion of matter. The constant temperature at which a solid turns into corresponding liquid is called melting point of the solid. It is a definition of a melting point of solid, that is very important for you. The constant temperature at which a solid turns into the corresponding liquid is called the melting point of the solid. And same way, the constant temperature at which a liquid freezes, that is turns into corresponding solid, is called a freezing point of the liquid. What it is? It is a definition of the freezing point of the liquid. Okay. Please listen. The constant temperature at which a liquid freezes, that is turns into corresponding solid, that is called the freezing point of a liquid. Ordinarily, the freezing point of a liquid is same as the melting point of the corresponding solid. The freezing point and melting point are almost same, in every case the same. For example, water freezes as well as ice melts at 0 degree Celsius. Water freezes and also ice melts, this both are at 0 degree Celsius. Also, the constant temperature at which a liquid boils is called a boiling point of the liquid. A constant temperature at which a liquid boils, that is called a boiling point of the liquid. For example, the boiling point of the water is 100 degrees Celsius. It is temperature at which steam will condense. Okay. Today we have discussed some important points. First one, molecules, then intermolecular space, then intermolecular force, then we have discussed states of matter, today. Then we have discussed about the intermolecular space, the relation between intermolecular space and intermolecular force. Then interconversion of matter, Then finally, we have discussed that freezing point, melting point and boiling point. So, there are many definitions for you tomorrow. Tomorrow you learn and come, underline and learn and come these all points, these all definitions. And if you have any doubt, you can ask to me doubts and messages and also directly tomorrow, next class. Okay. Tomorrow please learn and come, and thank you and goodbye students.